Good.
It's okay, thank you. I want us to begin. The last lesson we looked at Euclidean algorithm. Then we also looked at the extended Euclidean algorithm and how to implement them in Rust. So today I want us to look at something slightly different, and we'll be looking at the number systems, how to change from one numbering system to another. The number bases, I've called it number bases. Now, again, we had already looked at this, so we'll just look at a review, then we go to how it's implemented in Rust. Now, there are several. So what we're talking about, just talking about a number given in a certain base. For instance, the numbers we usually use, the ones we usually use is 0 to 9. These are, the base is 10. The base is 10, so we call them the decimal numbers or the denary numbers or the denary numbering system or decimal numbering system. So the base is 10. For instance, if you just write 7, 8, 9, without specifying the base, somebody will know that you're referring to a denary numbering system. The base is 10. The assumption will be that the base is 10. But if you want to use a different base, then you may want to show us by a subscript. For instance, I've used subscript 16, which means these numbers, the base is 16, for instance. So when the base is 10, like in this case, then we are using numbers 0 to 9. That means you can write something like 99, right? As in like 12, 13, 23, and so on. When the base is 2, for instance, we are using numbers 0 and 1. That means the base is 2. So you can have something like 0, 0, 1, or 1, 0, 1, 0, 0, 1, but you don't expect a digit that is greater than 1 here. So when the digit is greater than 1, you reduce it mod 2. So because the base is 2, so you reduce it mod 2. We've looked at modular arithmetic before. Now we can also talk of base of 7. So we'll be using numbers 0, 1, 2, all the way up to 6. So I can talk of 65 base 7. So you remember that if the base is not 10, then I have to show what my base is. Otherwise, if I just remain silent like that, somebody will think that the base is 10. Now, so you see, this number cannot have a digit that is greater than 6. A digit that is greater than 6, you reduce it mod 7. Now, but what we're interested in is, supposing we are given a number in a given base, can we change it to another base? That's what we'll be looking at. And it's very important, especially we looked at how a binary numbering system was very important in successive squaring. And that is why we bring in this idea of changing bases. So for instance, this number is base 10. Is it possible to change it to base 2? That is the question we'll be answering in this section. And if you are given a number that is in base 2 like this, which is in base 2, can you change it to base 7 or base 8 or base 16 to another base? Can you do that? That is the question we're supposed to be able to answer by the end of this session. Now, so I've said computers are based on binary system. These are systems that use, this is base 2. When the numbers are written in base 2, we call it a binary system. When they're written to base 10, we call them either decimal system or denary system. So the binary system, as we said, uses numbers 0 and 1 only. You cannot have a number that is greater than 1. Now, so we begin what we want to do. We want to convert, we will begin by converting a number that is in base 10 to any other base. So we've said to convert a number from base 10 to another base, we use division algorithm. So what I mean here, if I have a number in base 10 and I want to convert this number to base 8, I'll divide that number by 8 successively. And every time I do that, I note the remainder. Every time I do that, I note. So if I want to change a number that is in base 10 to any other base, even if it's to base 16 or to base 25, I divide the number that I'm given by the new base that I want to change to. Now, I've said, for instance, to convert a denary number or a decimal number to a binary, you repeatedly divide the number by 2 and note the remainder at every stage. And of course, when we write the code will just be doing exactly that. We will have to ensure that we give it a number, then it divides that number successively by the new base to give us then a number in that new base. Now, the example is here. I have this number 53, which is a decimal number, and I want to convert this to binary. So binary means base 2. So that means I divide this number by 2, and every time I note the remainder. So in other words, we're just using division algorithm. Just using division. So we ask ourselves, 2 into 53, how many times? What is the remainder? We are interested with the remainders. Now, what about 2 into this 26? To be 13 times, the remainder will be 0. What about 2 into this 13? So 2 into 13 goes there 6 times, the remainder is 1. What about 2 into this 6? So 2 into 6, it goes there 3 times, the remainder is 0. What about 2 into 3? 2 into 3 goes there once and the remainder is 1. What about 2 into this 1? 2 into going to 1 0 times, and the remainder will be 1. After that, we write these remainders from the bottom going up. So the first remainder there is 1, followed by this 1, then followed by 0, followed by 1, followed by 0, followed by 1. This is the new number that we want in base 2. So this is the number, the binary number we wanted. Now, so that is if you're given a number that has no decimal. I've just been given a whole number. A whole number. In my program, in the program, I call it an integer. I call it the integer. So this is a number that has no decimal. What about if I'm given a number that has a decimal, like 0.53? How do I convert that to, well, this is a decimal. How do I convert that to binary? That is the question. Let's just do that, and then we go straight to the Rust code and just see if we can implement that. Now, so the fractional denary numbers can be converted to binary by repeatedly multiplying the number by 2 till we get 1. So you multiply by 2, and then again multiply by 2, and then again multiply by 2. But we are just multiplying the decimal part. Now, so I've been given this number here. is a decimal number. I want to convert this to binary, base 2. So I multiply this part, this decimal number by 2. When you multiply by 2, this is what you get, 1.625. 1.625. Now, I'm interested with this decimal part. I want this decimal part to become 0. So that I have 1.0. So I want this decimal part to become 0. So again, I multiply this decimal part by 2. I get 1.25. Also, I have this decimal part. Again, I multiply this decimal part by 2. I get 0.5. So the decimal part is still there. Again, I multiply by 2. I get 1.0. So I've achieved what I wanted. So 1.0. You can see I was cycling these integer parts, the whole number parts, these integer parts, I was cycling them. Because I'm only interested with this part. This part must become 0. Once it becomes 0, I multiply the integer. I write the integer part from up going down, from up going down. So the integer part from up going down, what I have is 1, 1, 0, 1. But the number I was given was a decimal, so I have to remember that. So to remember that, I just put a 0 there and then write the decimal here and say this is the binary number. So I was given the decimal number. I have written binary number, and you can see what we've done. The procedure we've used. We take the decimal and just multiply by 2. When you get a decimal number, extract that decimal again, multiply by 2. When you get a decimal, extract that decimal again, multiply by 2, until you arrive at 0.0. Now, so what if you are given 53.8125, which is a decimal number, and you're supposed to convert this to a binary? And I've just used 2 as an example, because if you're asked to convert this number to base 8, if the question was convert this number to base 8, then you are just doing, now you just replace the 2 by 8. Just replace the 2 by 8. You multiply it by 8. If you get a decimal here, take that decimal, multiply by 8 again, continue that process until you arrive at 0.0 at this point. So I'm just using 2 to stand for any other base. I'm converting from base 10 to any other base. So 2 is just an example. If I'm told to convert this number to base 7, it is already in base 10, so I want to base 7. So where there's 2 here, just replace by 7 and multiply it by 7, multiply by 7, and so on. So now the question I want to answer is, supposing I have a number that is mixed, the integer part and the fractional part. I want to convert this number to binary. For me to do this, I separate these 2. I deal with each individually. I deal with this one first, 53, deal with 53 first. I'm not dealing with 53 will entail dividing it by 2, and until I have 0. So I'm dividing. And then I come to this one again, deal with this one. And I know that to deal with this one, I'm multiplying it by 2 and multiply by 2, multiply by 2, and then write these numbers from up going down. The answer that I get here, I combine with the answer that I got up there. Then I have the decimal, the binary number. For instance, this question, the earlier part I had gotten 1, 1, that, so I just write 53 has given me 110101. Now where's 1101? There's a 0 here. It's not writing there, but let me just write it here. I have 110101. Since I want to find the binary number here, the binary number equivalent to this decimal number, I would put a decimal here and come and read this other result. This other result is 1101. So I combine the two results, and this is the binary number. That is the binary number. So now when you're writing Rust, again, you must note that you can be given a number that has no decimal like this. It should be able to deal with this part. Then you must know that you can be given a number that has a fractional part. It should be able to deal with this type of number. And how does it deal with this type of number? It should be able to do what we've just done. What we've done was we separate this into two. We worked with the 53 first, then worked with the 0.25, then combined the two results. That is the only way you can write it. So you must ensure that it can work with the 53, the integer, then work with the fractional part, then combine the two results. Now, so, okay, I was supposed to show an example of how to convert from base 2 to base 10, and also convert, the way you convert from base 2 to base 10, again, we shall generalize and use the same method, convert from base 8 to base 10, and so on. And we can also convert from base 2 to base 8. Now, but let me show you the code first, and then I'll explain those others. But before I go to the code, for me to convert from base 2 to base 8, the easiest way to do that is first of all to convert base 2 to base 10. First of all, I want to convert from base 2 to base 8. There's no direct way. There is no direct way of converting from one base to another base without, you see base 10, let me just check out, let me ignore base 10 first of all. These are the bases. There's no other way of converting from one to the other. These are the bases. There's no easier way of converting from one to the other. So the only way we do that, to convert from base 2 to base 8, I must first of all convert base 2 to base 10. And I know how to convert from base 10 to any other base. I know how to convert from base 10 to any other base. So I can do that. So if I'm given base 8 and I'm supposed to convert that to base 25, there is no direct way. So I would first of all convert this to base 10. And then I know that base 10, you can always convert to another base. So that means that I'll have converted from base 8 to base 25. And so that again, if you're writing a code, the code must be able to know that. It must be able to know that for you to convert from base 2 to base 16, it must pass through base 10. Then from base 10, it converts it to base 16. So that it must. So there are various things that I've mentioned that when you're writing this code, you must instruct it to do. Converting, if you, for instance, you want to convert 53.67, you must know that you'll first of all work with 53, then work with the 0.67. So the Rust code is here. Now what I put here, this is just a number to base 16, number to base 16, number to base 16. I'll show you, but it's normally 0, 1, 2, all the way up to 9. Then from 9, we have A, B, C, D, E, F. How many numbers are these? These are 9, 10, 11, 12, 13, 14, 15 numbers. 15 numbers. Because when you are talking of base 10, you're talking of 0 to 9. Those are 9 numbers. Are they 9 or 10? These are 10, eh? Yeah, there are 10. These are 10 numbers. 10 numbers. Even this one are 16 numbers. 16 numbers. Because 0 to 9, these are 10 numbers. These are 10 numbers. Because 1 from to 9 is 9 numbers. Then plus this is a 10, 11, 12, 13, 14, 15, 16 numbers. So the number I've just written here is 1, A, 5, C, 0.2. This is to base 16. And you can see my code. I've said let number. So this is where you put the number you want to convert. I've given an example of base 16, but you can have base 2, you can have base 3. We shall see how the code runs. And you then state the base of the number here. So the base of this number is let from base, the base we are converting from is 16. So this is just the base of this number here. And then let to base, the base we want to convert to is base 10. So I want to convert this number to base 10. That's what I want to convert. So this is the main function. The main function, you just, this is what you state there. You state the number you want to convert, then you state the base from which that number is coming from. Then you also state the base to which you want to convert your number to. So that is the main function. And the main function would then, look what I've written here. What I've written here, it means it will give me a result, some result. The word is some result here. If the result exists, then it gives me that result. If the result is not there, then it does not give me the result. It will give me an invalid input. And that is what it prints. It prints the number that you wanted to convert in base, the base that you want to convert from. For instance, this case, it will write this number in this bracket in base 16 is, then it gives me the new number in base 10. So it gives me the number, that is the number you put here from base, which is 16. Then it gives me the result to base, the base we are going to. That is, if there is some result. If there is no result, if there's none, result is none, it will print invalid input. Invalid input. If the result is none. Now, so I'd say that there are several functions we define. The first, the main function we've already defined that one does not have much, but this other function I've defined. And I've said function convert base. And there's a string, the number should be like a string, is from base, and the number here, the base here should be U32. And we've been talking about U and also talking about I32 and so on. where 32 are the bits. And to base, this is from base, The base you're coming from should be U32, because we cannot talk of, cannot talk of a number to base negative 2. We don't have base negative. The base is either base 2 or base 3, and that is why it's U. When we talk of U, we are only interested with the positive numbers. So the from base, that base should be a positive number. That is what this means. And the base we are going to is also a positive number. It's also a positive number. Now, what does this function do here? This function will be converting, and that's what he said. If you have this number, convert to decimal. Convert to decimal. And then there's some. There's some there. Convert from decimal value, and that is if there is a result. If there's a result, and that is why that sum is there. If there's a result, and we already said that if there's no result, then it will be invalid. I've also defined another function here, and of course, below my notes, I've given the explanation for each of these. Now, this one, convert to decimal. Convert to decimal. And of course, this the number should be a string, of course. And then the base should be positive. And then what we get is option F64. Now, option F64 is what I've already explained. What I've already explained is that we have two possibilities. We have possibilities of getting a result, a valid result and an invalid result. So that is what the floating 64 bits implies here. Now, so the thing is, the number is being converted to decimal. And I've already said that if you have two bases which are different, for example, base 2 and base 8, you want to convert the number to base 8, will first of all be converted to decimal before it goes back to base 8. Now, look at what is here. This one is taking care of what we've already explained. That, for instance, if you have 53.025, first of all, this code is converting this integer part. That's why I've said convert integer part. So this is to convert this integer part. Then we have the fractional part. And so this is a case where I've been given a number like 110 base 2, and I want to convert to base 8. I've said this number will first of all be converted to decimal and then converted to base 8. But again, as it does that, this integer part will first of all be converted alone, and then this other fractional part converted alone. That's what you're seeing here. And again, I've said some integer value plus fractional value. So what it's doing is, after it has gotten the result, it combines the two results. But if there is some result, that is what it will then do. Of course, if there's no result, it will be invalid. Now, there's another function, convert integer part. This is just alone now, converting. This is now the integer part will be converted. Again, the number should be a string, and the base be U32, option F64. And then it converts to give us a number. in the new base that we want. Then convert the fractional part. Again, the options are there. Now, convert from decimal. You want to convert from decimal. You see, I've combined all of those. You can have a code. In fact, you can write a code for only converting decimal to binary, and write a code for only converting from binary to decimal, and then write a code for only converting from base 2 to base 8, then write a code for only converting from base 8 to base 2. And I've combined all of them in so that this code can convert any of the bases to any other base. So I have this part for converting from decimal so to any other base. And I've said, of course, it will be converting also the integer part and converting the fractional part and so on. Then I have this convert integer to base. This is the new base you want to go to, and so on. Now, so I've added notes for these explanations. Let me just try and run the code so that we see if it can run. Just a minute. I try to open it. Then after opening, I'll stop sharing what I'm sharing. Then I try to share it. Okay, I've now opened it. Okay, you can see what I'm sharing. Is that okay?
Yes.
Okay, so I've just begun with the number that I was explaining. This is a decimal, this is hexadecimal number, base 16. And of course, I note that I want it to be it's from base 16. I show that it's from base 16 because there are numbers that they could be in base, they can be in base 8 and also in base 10, for instance, and you cannot tell if somebody does not indicate the base. So you must indicate the base. And then we want to convert to base 10. So that is what I then put here. Let us run. And it writes and says that this number, which is in base 16, is this in base 10. So in base 10, this number is this. So what it did, basically what it did, it converted the integer part just before the decimal. When it converted that integer part, the result was what you see on the right. It was 6448. 6448. Let's just run the integer part alone and see what we get. Let's remove this 0.2 and put 0.0. Just a minute. And put let's see whether we get 6748. Let us run. Yes, it has told us the left side was giving us just 6748. So you see, that's what it does. It first of all works with what is on the left side, first of all, and then work with what is on the right side of the decimal. Then combine the two results so that when we return 0.2 there, then it's able to give us a different result. Good. Now, what I want to do, I want to convert this result to base 10 and see whether we get the same result. I just want to copy it here at the bottom here and insert it here. I want to paste. And I have to remember that the number I'm dealing with now is base 10, and I want it converted to base 16. And then I say cargo run. And it's telling me that the number in base 16 is this, which is the number we had earlier. Now we can convert this number is in base 10. Let's convert to base 2. Let's convert to base 2. That number to base 2. Base 2 is this. The number at the bottom here. Remember I said if you want to convert from base 2 to base 16, first of all, you have to convert to base 10. Then from base 10, convert to base 16. But this code, I've made it such that it does all those. It converts to base 10, then converts to base 16 for you. Let me convert this number to base. I just want to copy it to base 16. Let me see whether I get what we had. This is a binary number. I want to convert to base 16. It gives us what we had at the beginning, which is 1A5C.2. So that is the number in base 16. So it's able to do that. So we can convert numbers from any base to another base. Let me change it a bit. And remember what we said last time. There's a U32 here, U32. If you want to deal with very big numbers, you can change to U64 and change to or 128 and above, so that you can deal with the bigger numbers, very long numbers. Like, let me talk of this number. Let me see whether this one is long. This one is in base 10. Let me convert it to base 16. Let's see whether that will happen. That's converted. In fact, in base 16, it's a very short number. It's here. The result is here in base 16. So it has been converted. But if we talked of base 2, it might be longer or what? Let's convert to base 2. It's a very long number here in base 2. It is here. Now, okay, that is how we do it. Let me see whether there is something here under cargo tome. In fact, there are no dependencies. I didn't put any dependencies here. So the code just runs the way it is. So this is the code. You can try and modify it. Try and modify it and see if it can convert numbers from one base to the other base. But as I said, you can want to just have a code for converting from one base to another base, from another base to another base. And so that means you'll have several codes. That's what I was trying to avoid. So I made one code for that will do for me all the conversions from any of the bases, whether the base is 10 or the base is 20 or the base is 1,000 and so on. It will still do that. Now, so what follows just how to understand every bit of the code, the main function, what it does there, defines the numbers to be converted, the base of this number, and the base convert to. So the base from where you're converting, we call it the from base, then to base, then calls convert base with this base from and to base. Then it prints the result if the conversion is successful. Otherwise, it will print invalid. And that's what we saw. Let's just go back to the main function and see what we just talked about. The main function is here. So you input the number, and then you tell the base from which that number is. Then you tell the base to which you want to convert. And then it will print result if the result exists. And if there is no result, it will print invalid. That is the main function. Then there's this other function, convert base function. This takes the number as a string and from base and to base as unsigned integers. Unsigned integers, say these are positive integers. These are post 0 and so 0, 1, 2, 3, and so on. So it will be, and also, of course, the base, we say the base cannot be negative. The bases cannot, the base from and the base to cannot be negative. And that is why we had U32. It converts this, the second function also converts the number from base to a decimal value. So that is what we said. We said, for instance, you want to convert from base 2 to base 8. It will convert that, first of all, to a decimal value before it goes to the base you want. And here it has said, converts this decimal value to base, the base you want. And then it will return the result as a string. So that is what that second function is doing. You want to convert from base 2 to base 8. it will convert to decimal, first of all. It will convert to decimal. Then this decimal value will be converted to the base you want. Then there's the third function. We call it convert to decimal function. What this one does, it understands that if the number has an integer part and the fractional part, has to split those two first, so that it deals with the integer part and then deals with the fractional part separately. So it splits the number into integer and fractional parts, then converts each part to decimal separately, then adds the results and returns the sum as option F64. And I've explained what option F64 means. I've said this part represents a 64-bit optional floating point value, which is used to handle cases where a value might be present or absent. In other words, the result is there if there's some result, or if there's some value, or there is no value. So that is why you use this option F, just a floating point value. Now there's another function to convert integer part. Now just after the parts have been split, after they have been split, or supposing you have already the decimal number, you have already the decimal number there, and this decimal number has the integer part and the fractional part. Convert the integer part to convert the integer part of integer part of the number from the base that you want to convert from, to the base you want, using this I64 string radix. Radix is just a base. Right? The word radix just means base. Then it returns the result as F64. Then we have these other two. Convert fractional part. It will also be converting the fractional part. Then this other one converts function from decimal. So this one converts the decimal number to the target base, splits the number into integer and fractional parts, then converts each part using convert integer to base and convert fraction to base. Then finally, we have these two. You look at them again. So all these functions are there, and each one of them has, there are several because we are converting very many numbers here. We're converting from base 2 to base 10, then from base 2 to base 8, and so on. And I said, if you want them to be few, you can just measure on one conversion. For instance, if you just say you want to convert from binary to decimal and back, then that would be a very short code. A very short code. Now, so I've shown you how to use the Rust code. And of course, I showed you two examples of how to convert decimal to binary. I will not show you how to convert from binary back to decimal. I'll show you the examples I have here. How does it convert from binary back to decimal? Now, octal system uses numbers 0 to 7. So we can convert a decimal number to octal. And I said, converting from decimal to any other base, just the same thing. Just the same thing we did earlier. When we converted to base 2, when we converted a decimal number to base 2, we divided by 2 repeatedly, noted the remainders. Now that we are converting from base 10 to base 8, we will divide by 8 and note the remainder at every stage. So the number that I'm given, divided by 8, the remainder is 6. Divided by 8, again, the remainder is 5. Divide this one by 8. Okay. Okay, so let me just again begin. Divide this by 8. 8 goes 85 times. The remainder is 6. What about 8 into 85? Go there 10 times. The remainder is 5. What about 8 into 10? Goes there once. The remainder is 2. What about 8 into 1? So until the remainder is 0 here. So it goes there 0 times, and the remainder is 1. So this is the integer part we are talking about. It has not decimal. That's the integer part. So now we write our remainders from the bottom going up. So the octal number is 1256. 1256. Now, if it had a decimal, supposing we had this number, and we had to convert to base 8, we would do what we did earlier with base 2, multiply this number by 8, not what you get. Supposing I get, let me just find out what I get. It looks like 1 point something. Let me make it a bit, let me make it 2. Make it 2. Make it 2. Suppose I have that number, which is 0.225. I would multiply that number by 8 and get 1.8. So this decimal part, I would again multiply by 8. And so what I get, 0.8, 0.8 multiplied by 8. I get 6.4. So this decimal part, I would again multiply by 8 until I get 0 at this point, until I get 0 there. So what is that? 0.4. 0.4 times 8. Give me 3.2. This decimal part, I will say multiply by 8. 0.2 times 8. I'll get 1.6. This 6 part, 0.6 part, I'll say multiply by 8. Can continue, but it will can continue. I get 4.8, and so on. Now, no, it's not a mass it can terminate. Sometimes you can get recurring. Get something that is recurring. For instance, in this case, I point it back here, and so on. Let me just look at what the code gives us. Let's go back to the code and see what it gives us, that number. Let's see what the code will give us. Okay, the code is there again. I wanted to convert 0.2225 decimal to octal. Let's see what we get. Yeah, it notes that there's some recurring here because there's 1, 6, 3, 1, 4, then 6, 3, 1, 4, 6, 3, 1. So it will be recurring. There's 0.1631, then 4, but 631 is recurring. 631. 4. 6314. It means 6314 is recurring. That's what we were beginning to see. We were beginning to see that there was some recurring. What was recurring here? Because, yeah, you see, there's 1, then 6, 3, you see, 1, 4, and so on. So those whole numbers, the recurring 6314. So that's how you convert from decimal to base 8. If you're given a whole number, we've seen that we would divide and not the remainder. But if you're given a decimal, a fractional part, we've seen that we would multiply by 8 and not what we get, and continue that multiplication. And of course, I've shown it here. This example takes care of that. I'm given a decimal number here, and that is okay. So we can convert from any base. From base 2, from base 10 to any base using the same logic. Can convert from base 10 to any other base using the same reasoning. Look at this one. I was now converting from base 10 to base 7, and I was just emphasizing that it's the same way we do it. Divide this number by 7, not the remainder. Then divide this again by 7, not the remainder. And then divide this again by 7, not the remainder. Divide this by 7 until you have 0 here. And then write these remainders from bottom going up. And if you have a decimal number, again, it's the same way. You multiply by 7. Hexadecimal, I had talked about this. These are numbers from 0 to F. These are 10, 11, 12, 13, 14, 15. Is F. Numbers from 0 to F. Where A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So you have numbers from 0 to 15. But now, instead of 10, it's A. So if I talk of AB, what is this number? This number is like 10, then 11. But we don't write like this. We write it AB. So A would represent 10, and B would represent 11. So I have this number. I want to convert to hexadecimal. It means I must divide by 16 and not remain at every stage. Okay. So I divide by 16. This number divided by 16. The remainder is 8. And then this number divided by 16. The remainder is 9. This number divided by 16. The remainder is 11. But I don't write 11. 11 is B. This number divided by 16. So 16 goes there 0 times. The remainder is 10, but it's not 10, it's A. Then I write them from the bottom. So it's AB 9, 8. So this is the number to base 16. That is the number to base 16. Is it? Well, I interchanged this one when I was writing. It was supposed to be 98, not 89, because you are writing from the bottom going up. AB 98, not AB 89. I think I saw this one, then I saw 8 first. The same thing with the fractional part. If you have the fractional number there, multiplied by 16, then this fractional part, multiplied again by 16, then this fractional part, multiplied by 16, until you have a 0, and then not the remainders, no, the whole numbers here, the cycle ones, from this time from up. But this is 10. 10 is A, and then 9. Then we remember it was a fraction part. So this is to be 16. So that's how we do it. Now, I think it's now good to see how to convert from another base to base 10. Because we said for us to convert from base 16 to base 2, first of all, base 16 has to be converted to base 10. Then from base 10 to base 2, we've already seen how to convert from base 10 to another base. So we need to see how we convert from a base to base 2, not to base 10. I begin by an example. Okay, so this was just an explanation. It was an explanation that if you are given a number like, and this explanation is what assists me to see how to come up with a method of converting. Because if I'm given a number like 235, this number is the same as if I had to begin from here. Let me begin from this side. How many zeros do I have? Okay, we learned something called total value. Total value of this number is 200, which we write as 2 times 10 raised to 2. And total value of this number is 30, which we write as 3 times 10 raised to 1. And then the total value of this is just 5, which is 5 times 10 raised to 0. So this number is 200 plus 30 plus 5 gives you 235. So the same thing to this. Same thing to this would be total value of this is 700, which you write like that. Total value of this is 20, which you write like this. Total value of 3 is that. And then from here, this is now a decimal part, the fractional part. This is the same as 5 out of 10, which you can also write as 10. 5 times 10 raised to negative 1. And this other one is 0.06, which you can write as 6 out of 100, or 6 times 10 raised to negative 2. So we use this knowledge, therefore, to write a number from another base to base 10. And let me show you how we do that. I begin with this binary number. Begin with this binary number. I want to convert it to base 10. So to convert to base 10, I must know that this number is to base 2. Now, when this number was to base 10, I was multiplying by 10, where 10 is the base of this number. 10, this 10 is the base of this number. This 10 is the base of this number. Now, this number we have, the base is 2. So instead of 10 in this example, we are using 2. So let's begin from here. Let's begin from this first number. It is 1. The base is 2. How many zeros? 1, 2, 3, 4. Total value. Just talking about the total value. Then there's this 1. The base is 2. This one is the one I'm talking about. Then we are left with how many zeros? 1, 2, 3. And then plus 1 times 2, which is the base. Is it 1? Yes, this one is 1. And we are left with only 2 numbers to reach the decimal. Only left with the 2 numbers to reach the decimal. And then we have 0 times the base, which is 2. And from this 0, we only have 1 number to reach the decimal. Then finally, we have 1 times 2. And to reach a decimal, you have 0 numbers. You have 0 numbers. So you have already dealt with this part. We have dealt with this part, which you can use your calculator. 2 raised to 4 is 2 times 2 times 2 times 2, which is 16. And 2 raised to 3 is 8. 2 raised to 2 is 4. And then this multiplied by 0 will be 0. And then this 2 raised to 1, 0 is 1. 2 raised to 0 is 1. 1 times 1 will be 1. When you add this part, 16 plus 8 will be 24, then 28, and then 29. And there is the 29 you're seeing here. Now we deal with the fractional part, the part after the decimal. The part after the decimal. We have this part, which is 1 times 2 raised to negative 1. Yes, from the decimal, when we just count, the same way we are counting in high school, the integers, negative 1. Then plus 1 times 2 raised to, now when you come here, to be negative 2. Now, negative 2 raised to negative 1 is just a half. And this other one is a quarter, which when you use your calculator, in fact, the LCM is 4. Or there are 2 times and 1. This will be 3 out of 4, which is 0.75. And it's what we are seeing here. So we combine the 2 results. And that's how we do it. Now, this is when the base is 2. We generalize the same if the base is 8. We generalize the same if the base is 7. So what is only changing is where there's 2. If the base is 7, where there's 2, putting 7. Where there's 2, you're putting 7. Where there's 2, you're putting 7. That's the only thing that is changing. When the base changes, that's the only thing that it changes. And there's this example to just emphasize that. Of this number, which is octo, meaning the base is 8, convert this to base 10. So you begin this number here. 1 times 8 raised to how many zeros? When you write, this will be, we talked of what were decimal places? Yes, decimal places. So these are 1, 2, and then plus 5, followed by 8. We only have 1 number to the decimal. And then plus 7 multiplied by 8. You have 0 numbers to the decimal. And then 6 times 8 raised to negative 1. And that gives you this, because this is 64. And this is 40. And this is 0. This is 64. This is 40. This is 7. Because this is 8 raised, that is 7. 8 raised to 1 is 1. 8 raised to 0 is 1. 1 times that is 7. Then what is this? This is 6 out of 8. 6 out of 8, which is 3 out of 4, which is 0.75. But this other part, this is 104. 104. What is it? 64 plus 40, 104. Then plus 7, which is 111. Then plus 0.75. No. Plus 0.75. That's what you get. Good. That's how you convert numbers from one base to another base. And what is very important is that if you have to convert from base 3 to base 4, first of all, convert base 3 to 10, then from base 10 to 4. And so when you're writing your code and you want to combine all those, then you have to just remember that if you have to convert from several bases to other bases. Thank you. So you'll go through these other examples, just I've included them here and the workings are there, but of course you can use the code that we have and the code will be doing all this for you.